Welcome back. This is lesson 16.3. In the previous few lessons, we've been looking at writing programs using assembly language, in particular LMC. In this lesson, we'll just have a quick overview of what low-level languages like assembly language are. We'll begin with a short memory test, see if you can remember what we've been learning about the way that the processor is structured. And we'll compare machine code and assembly language, which are low-level languages, with the high-level languages such as Python. But first, let's have a quiz. This is just a memory test of what we've learned in previous lessons about the structure and function of the processor. So can you remember what was von Neumann's big idea about the structure of the processor? How are instructions stored in RAM? What's the instruction set of a processor? And what is machine code? So get a bit of paper, write down your answers to those questions, pause this presentation while you write that down. I'll show you the answers on the next page. So von Neumann's idea, the structure of a von Neumann machine, is that instructions are stored in RAM alongside data. That's why they're called programmable computers. We can change the instructions because they're stored electronically in RAM, and the instructions are stored as binary numbers. Everything in RAM is stored as binary numbers. The instruction set of a processor are the codes. It's a set of all the codes that the processor can understand, all the instruction codes that the processor can understand. And machine code is a way of programming the computer by entering these instruction codes directly into computer memory. So machine code consists of numerical digital codes that stand for actions that the computer can carry out. Machine code and assembly language together are what we call the low-level languages. So let's learn a little bit more about what that means. In machine code, as I've said, the instructions are stored as electronic binary numbers, and each number is code for one operation of the computer. It can be converted directly one-to-one. Each number stands directly for one action of the processor. The control unit reads those numbers and converts them into the correct control signals and sends out a control signal. Following each number sends out a different control signal to make the processor do something, such as add. So a program is just a list of these number codes, and those number codes are converted into operations of the computer. The instructions of assembly language generally match pretty closely to the numbers of machine code, but instead of being electronic binary numbers, they are short words. There's an example on the screen. It's not the one that you've learned, it's not the assembly language you've learned, but you can see how the principle works. There's a quite close match-up between assembly language instructions and the machine code instructions. So the instructions in assembly language are not actually binary numbers. That's why they're easier for us to understand, but they need to be converted into binary numbers before the computer can read them and follow them. So there has to be some conversion process. It's a fairly straightforward conversion process. The words of assembly language are converted directly into binary numbers by a piece of software called an assembler. So machine code and assembly language are very similar. They're quite close to the instructions that the hardware can understand, that a processor can understand and carry out. The code is generally very fast and it works very well with the features of the processor. There are many disadvantages, however, to writing a program in a low-level language. Programs are much harder to write and to read than programs in high-level language, and you will know this because you've written instructions in assembly language, programs in assembly language, the Little Man computer language, and you've written programs in a high-level language, probably Python, and you'll know how much easier it is to write in Python than in LMC. Despite that disadvantage, there is some programming still done in low-level languages. Very short programs where the size of the code and the speed of the code are extremely important, and sometimes people make changes or edits to low-level language programs, particularly programs that work directly with the hardware, such as system software and utilities. So lower-level languages do have their uses, but they're not as widely used as high-level languages like Python. Because high-level languages are more like human language, they're less similar to machine code, because they're designed to be easier for us to understand. They are easier for us to use, and it's easier for us to do much more complex tasks with them. They don't give us the same amount of control over the fine detail of the instruction cycle, but that's generally a price worth paying. So this table on the screen just compares what I've been saying about the advantages, disadvantages and uses of high and low level languages. So if you think you need that on the screen as you write it, pause the presentation now and make a copy of that. Otherwise, commit it to memory and write it into your revision guide when you get the chance. So I'm just going to leave you with an activity, a bit of programming to do in Python. As you know, LMC is a pretend assembly language, so I'm challenging you to write a pretend assembler to convert any LMC program, read it line by line and convert it into numerical form. You can look back at previous lessons to find the number commands that correspond to the words of the LMC language. So read an LMC program into your program, your assembler, and output the same commands but now in number form. And if you get all that working, why not convert it all the way into binary and store those binary machine code, pretend machine code programs as files onto your hard disk. So that would be quite an interesting exploratory task to learn a little bit about what an assembler is. However, do remember that the machine code that you'll be creating won't be real machine code and you won't really be able to run it on the computer. But I think it'll be an interesting programming activity. Okay, so in the next series of presentations, I'm to look a little bit more at high-level languages and what it is to write programs. But for now, bye for now.